In this video, we'll cover the JPA development process. Here's the JPA development process, our to-do list. The first thing we need to do is annotate the Java class, and then we need to develop the Java code to perform the database operations. Let's just say JPA. As mentioned, Hibernate is the default JPA implementation in Spring Boot. Going forward in this course, I'll simply use the term JPA. Instead of saying JPA Hibernate or Hibernate JPA, I'll simply say JPA because we know that by default, Hibernate is used behind the scenes. For terminology, we have this term called entity class, and that's a Java class that is mapped to a database table. And here we'll make use of this object-to-relational mapping. Again, mapping a Java class to a database table. We'll have this Java class called student that has 4 fields: ID, first name, last name, and email. We'll make use of JPA and we'll map it to a given database table called student that has 4 columns: ID, first name, last name, and email. And notice here the first underscore name and the last underscore name. So we need to kind of provide mappings between the two. At a minimum, the entity class must be annotated with the entity annotation. Also, it must have a public or protected no argument constructor. The class can have other constructors, but again, as a minimum, you must have a public or protected no arg constructor. And now just a quick refresher here on constructors in Java. Now remember, when you're using constructors in Java, if you don't declare any constructors, then Java will provide a no argument constructor for free. However, if you declare constructors with arguments in your class, then you do not get a no argument constructor for free. In this case, you have to explicitly declare a no argument constructor. So again, be aware of that, and I'll kind of go through examples of the coding for this in this course. With our Java annotations, we have 2 steps here. One is mapping the class to a database table, and then mapping the fields to database columns. Let's get started here with step 1 of mapping a class to a database table. So we have this class student, we have this database table called student. Here I make use of this entity annotation for my class, and then I make use of the table annotation, and I give name equals student. That's the name of the database table that we're actually mapping this given Java class to. And then in step 2, we map fields to database columns. Here we have this class called student, and we need to map these given fields to the appropriate database columns. And I can do that by making use of the column annotation. Here I have column name equals ID. That's the name of the actual database column. For the next field here, first name, I have column name equals first underscore name. So again, notice here the spelling, there's different spellings here between the Java class and the actual database column name, and we annotate those accordingly. One thing to be aware of here is that the column annotation is actually optional. You actually don't have to provide it. So if not specified, the column name is the same name as the Java field. In general, I don't recommend this approach because if you refactor the Java code, like maybe refactoring the field name, then it will not match the existing database columns. And this is a breaking change, and you need to go through and update the database columns. This may not be a big deal for a very small, basic project that you're working with on your own. However, if you're working in a large company, working on an enterprise application at an MNC, then you can't simply go through and change database columns however you feel, because it could affect other teams within your company that are using that given database. So again, be aware of that. So I normally don't recommend this approach, but I wanted to let you know that it's available. Also, the same applies to the table annotation. If you don't provide the table annotation, then the database table name is the same as the class. Again, same thing applies here. I don't normally recommend this. I like to be explicit and annotate the class and fields accordingly. Here's another term here, primary key. So the primary key uniquely identifies each row in a table, must be a unique value, and it cannot contain null values. In the MySQL database, we can make use of an auto increment. So we can define our primary key, and then we can specify that it's an auto increment. So here I have a little snippet here, create table student. We have this column ID, it's of type int. We say it's not null, and then we specify auto increment. Behind the scenes, MySQL will keep track of automatically incrementing this ID and making sure it's a unique value. And also here, the line at the bottom for primary key, we specify that our given column ID, that this is the primary key for this given table. And then, so in the JPA world, we have to specify the actual primary key or the identity here. So we make use of this ID annotation, and then we specify how this given ID or primary key, how the value is generated. Here I make use of generation type.identity. What I'm saying is that this ID value will be generated by the database and managed by the database. There's no need for our code to manually try and keep track of that given ID. It's a generated value. Now, a bit more here on the ID generation strategies. The first one here is generation type auto. It'll basically pick an appropriate strategy for the particular database. Next, we have this generation type identity. That's the one that we're using. So we're going to assign primary keys using the database identity column or primary key column. Another approach here is the generation type.sequence. You can assign primary keys using a database sequence. And next we have generation type table. We assign the primary keys using an underlying database table to ensure uniqueness. And then finally we have generation type.uuid. Here we assign primary keys using a globally unique identifier or UUID to ensure uniqueness. In general, I recommend teams start out by using the generation type.identity, and that should cover most of the use cases. However, if you have very specific use cases, you can apply some of the other generation types based on your application requirements. Alrighty, now bonus. We covered a lot of good stuff here. You could say, hey, I went through the docs and I looked at all these other generation types. They sound interesting, but at my company on our project, we have a very specific requirement for generating the ID, and nothing that JPA provides out of the box matches our requirement. Okay, no problem. You can actually define your own custom generation strategy for generating your ID. You simply create a custom implementation of this identifier generator interface. You override the method or implement the method generate. And again, inside of this generate method, you provide your own custom business logic or corporate logic here for actually generating a given ID. So they basically give you an extension point where you can create your own custom generation strategy for creating your IDs. Alrighty, this all looks pretty good. Let's go ahead and move into the next video, and let's start mapping our class to a database table. I'll see ya in the next video. Yo.